then I'll go from there. So, good morning, everyone. So, thank you for being here today. My name is Ashraf, as Adrika already introduced me to you, and I am really excited to share our work on sustainable pavement solution on expensive soil using geocells and recycled asphalt pavement. And expansive soils have challenged our pavement for decades, and today I will talk about a practical, cost-effective, and sustainable solution for this problem. So you can see here is the outline of my presentation. I will begin with the background and challenges associated with expansive soils, followed by the limitation of current practices and the motivation for pursuing sustainable alternatives. Then I will walk you through the study framework, which includes material characterizations, field construction, and performance assessment. Finally, I will conclude my presentation with the key findings. So we know we are located in Texas, and we have a lot of issues with the expansive soil. Approximately 56% of the total roadways are farm to market road. And you can look at the map is most of the roadways are constructed over expansive subgrade soil. And if you look at the red zones in Texas, most of the major cities with densely populated areas are within this region. The presence of expansive soil amplified the pavement distresses, including rutting, heaving, cracking. So we are having lots of issues from the expansive soil, and the damage is around 1 billion per year, which is a huge amount. And if you look at the infrastructure report card for Texas in 2025, you can see the roadway grade is C minus, which needs to be improved. That's why tech engineers are trying to find some sustainable solution which can improve the road conditions. Let me talk about the expansive soil and how it impacts our pavement. Normally, expansive soils are made of plate-like particles, and one of the common minerals is for the expansive soil is montmorillonite. When these plate-like particles are negatively charged and attracts more bipolar water molecules. So during the time of wetting, you can see the water gets into the interlayer of the plate-like particles of the clay particles, and it causes the increase in volume, which is also known as heaving. And you can see in our pavement, we can have this kind of upward movement. And during the dry season, water are taking away from the interlayers, and you can see the shrinkage and reduction in volume. That will eventually lead to the bottom-up cracking. So this is the main reason why we have lots of cracks and depressions on road, especially farm to market road, where the pavement thicknesses are not that high. With that, we let's look at the current practices, like how the agencies are taking care of the problem. So one of the mostly used solution is the lime or the cement. But the problem is, if you use the lime has issue with forming ettringite in the presence of sulfate. So it is not suitable where the soil is sulfate rich. And also, the cement will make the soil more brittle, which may lead to the reflective cracking in the overlaying asphalt layer. Another issue, the long curing time. So this kind of solution may be useful for a new project, but for rehabilitation project where you cannot stop the traffic for a longer period, and this kind of solution may not be effective. Another way to treat the subgrade is by replacing the whole layer of expansive layer and replace it with the soil which is not swelling. But this is not cost effective and may not be sustainable because this is not practical as well. Another solution people do like moisture conditioning. So moisture conditioning, how it works, like if you add water such a way that during the time of dry season, it can like retain the moisture, but this is weather dependent. And if you have a very dry summer, water can take out, and reduction in moisture will leading to the shrinkage, cracking, and expansion of soil in the next rainy season. So this kind of solution um, have some limitation which justify the need for a more resilient and sustainable method. When you talk about the sustainable approach, there are a few things like we need to understand that the performance should have increased, or at least it has like it meets the requirement. We should have like reduction in cost, and also we should have minimum environmental impact. So what our agencies are suggesting for a sustainable pavement, for example, Federal Highway Administration, they urge us to use the recycled material to be used in the pavement. So with that, like what currently TechStart is doing, like for decades, TechStart are trying to use more and more wrap into the base layer, and the maximum percentage they use 20% by weight if they are blending with virgin aggregate, and up to 50% of wrap when they are stabilizing it with cement or fly ash. So they are not using 100% of wrap into the pavement. With that, back in 2011, Professor Jihan and his team from Kansas State University tried to use 100% of recycled asphalt pavement material, which is RAP. They tried to reinforce the RAP material with Geocell, and the base layer they called Geocell reinforced RAP base, or G. Any question? I think. Is there any question? Sorry to interrupt. I had some background noise. Okay, I'm continue with the presentation. So as you see, Professor Jihan from Kansas State University did some research with Geocell reinforced wrap based layer, and they found use of Geocell reinforcement can restrict the movement and reduce the permanent deformation. So this is the first time they were able to use 100% wrap for the base layer, and they prove it with the accelerated pavement load testing. Now, if you look at the figure side by side, you can see the unreinforced pavement section and the reinforced pavement section. So you can see the distribution of stresses with the use of Geocell. Now they are distributing to a wider area, which reduces the stresses, and eventually the deformation will also go down. So we wanted to use the similar concept for to control the movement of the expansive subgrade. If the subgrade is trying to move from the bottom, like it's going pushing up the pavement, the use of geocell reinforced base layer can help to reduce the movement. And that was the main reason we think about this study. Now I know like the question that is going through some of your mind, what is Geocell and how it looks like. So this is the picture for you. So Geocells are compressed panel when they are transported to the site. And when we expand the geocell, it forms a honeycomb shaped structure. And you can see the cells pockets are open, so you can fill this pocket with any kind of infill material like aggregate. It can be base, flex base, or it can be like recycle asphalt pavement. And the next question is, what is RAP or recycle asphalt pavement? This is basically the old pavement. When it reaches to the end of life, we milled this one and we try to store it to the nearby stockpile for future use. It is basically the aggregate with 4 to 6% of asphalt binder. And like we know we had the issue with the RAP that it has 1.7 to 3 times a higher permanent deformation compared to the flexless material. And traditionally, it is treated with fly ash or lime or a cement. So now the question is why we are looking for using RAP, because it will definitely reduce the carbon footprint and also reduce the cost. So the question is, the agency will always ask like, how you can prove it. We need some field demonstration. So there was a need for field study to prove the performance and to see whether it is sustainable or not. So throughout the remaining part of the presentation, I will talk about our study framework, explaining the mechanism, site selection criteria, material characterization, construction of test sections, performance monitoring, and how we assess the sustainability of the pavement. This is very important slide because we'll try to explain the mechanism of Geocell, how it works. So if you look at the cross section of the pavement, we know like the design life of the pavement depends on the vertical compressive strain that acts on the subgrade. So when we are loading the pavement from due to the wheel load, we see the base material will try to move in the lateral direction. If we can confine them with some kind of confinement, definitely the stress on top of subgrade will go down, which is technically reduce the vertical compressive strain on the subgrade. How you will define this additional confinement? We can actually do it from the triaxial test results. At the you can see at the center the results from the triaxial test. The first one, I'm just marking with a red circle, is the more circle is coming from unreinforced sample without using any geocell reinforcement. Now, we did another test with reinforcement, with geocell reinforcement. So when you do the reinforcement, then you will have a bigger circle. That means your capacity is going higher. Now the question is, if you think the material failure plane will remain the same, then you have to push the yellow circle towards the right until it reaches the failure envelope. So instead of the yellow, you can also explain it with the green envelope, green Mohr circle. And if you look at the confinement, you will see the initial confinement is now sigma 3 plus del sigma 3. That means there is an increase of confining pressure with the use of Geocell. So this is the additional confinement that Geocell is offering. And with this additional confinement, it will not only increase the strength, there will be impact on the stiffness. So let's look at the resilient modulus model for the pavement layer. We can see the resilient modulus depend on the bulk stress, which is theta. With the additional confinement, this bulk stress will go up. Now you have to look at the exponent K2 prime. If K2 prime is positive, that means increase of confinement will help you to increase the elastic modulus or resilient modulus. If the K2 prime is negative, then there will be no increment of stiffness with the addition of geocell. So we have to closely look at the material model, the parameters to make sure whether this geocell reinforcement will be helpful or not. I will show you our results in a minute. Let's before going to the results, let's look at our project site. So take start in Fort Worth area. If you can see in the map, we have a red zones. That means it's highly expansive. They were dealing with issues with expansive soil, especially for the farm to market roads, and they wanted a solution. They provided us 3 to 4 different locations where they have issue with the expansive soil, longitudinal cracking, heaving, and those kind of stuff. Even with the traditional method of treatment was not working. They tried to make overlay on top of the existing asphalt layer. Even after that, uh, the crack was appearing after every year. So the reason was the expansive soil and bottom up cracking occurs on the pavement. We collected the samples for different location, and finally we choose this location as you see in the photograph, which is FM 1807 Farm to Market Road, where the traditional approach of rehabilitation or like repairing did not work, and we selected this location for our study. And there was another criteria that we had to think about. We should have enough space in both sides of the road so that we can do our instrumentation. So we came up with this location which was suitable. So we start with the material characterization, and with the subgrade material were collected from the project site next to the pavement location. And when we check the unconfined compressive strength, which was very high, at optimum moisture content, definitely the strength of the soil may be very high, but when it swells, the strength will not remain the same, and also will have issue with the heaving. So we also did the swell test, and if you look at the swell results, it has 8.5% of swell, so it's like expansive soil. And if you look at the liquid limit, it was 58%, and plasticity index was also high. So the classification was high plastic clay in this project site. And we also look into the resilient modulus for this subgrade layer. And as I discussed earlier, resilient modulus depends on bulk stress and also the octahedral shear stress. If you look closely, look at the parameters, for example, K2 prime parameter for the subgrade or the clay material typically varies from minus zero point 0.1 to minus zero point 0.5. In our case, this value is minus 0.23. So basically, it's negative. So if we increase the confinement, the increase of confinement will eventually increase the bulk stress but reduce the resilient modulus because uh, the K2 parameter is negative. And also, if you look at the K3 parameter, which is positive, and it can range from 0.5 to 2 for the subgrade clay material, but increase in confinement due to geocell will eventually reduce the octahedral shear stress, and we can see there will be a reduction in resilient modulus. So we can conclude that if we reinforce the subgrade layer with geocell, there will be not there, there that will not be useful to increase the stiffness of the material. And for pavement, this is not useful to do reinforcement in the subgrade layer. That's why we reinforce the base layer with geocell. Now, let's talk about the characteristics of the base layer material, which is recycled asphalt pavement or RAP. And maximum particle size of wrap was less than 1 inch, and also it falls within the criteria defined by the TechStart. And we had collected the same samples, which is located very close to the project site, and the same material can be used for the was used for the construction of the test sections. And if you look at the K2 prime parameter, which varies from zero point 0.8 to 1, which is positive, that means if you increase the confinement, that means with Geocell, it will help to increase the resilient modulus. At the same time, if you look at the K3 prime parameter, which is negative, that means increase of confinement will reduce the octahedral shear stress, and eventually it will help to increase the resilient modulus. So we can say that reinforcing the base layer, the granular aggregate material layer, will be helpful to enhance the stiffness with Geocell. And this is the specification of the Geocell that we have used for this study. The cell size was 11.3 inch by 12.6 inch. And the panel size, when they are expanded, 8.4 feet by 27.4 feet. And if you look at the height of Geocell, it can vary from 4 to 8 inches. But in this study, we limited the maximum size of a Geocell height to 6 inch. It came from the TechStart specification of compaction. When you put the infill material into the Geocell pocket, you need to have at least 2 inch of clear cover on top of the Geocells. So with 6-inch Geocell and 2-inch cover, the maximum lift thickness is 8 inch. And according to TechStart specification, we cannot go beyond 8 inch of lift thickness. So that's why the maximum size of 6 inch can be used for the construction of pavement. With that, let's talk about some laboratory studies with Geocells. To simulate the pavement loading on Geocell reinforced wrap base layer, we constructed a test section, which is like 6 feet by 6 feet box. And you can see the bottom of the box, we had subgrade, which is 2 feet thick. Then we used geotextile for separation. On top of that, we had Geocell, which was filled with recycled asphalt pavement from the same source. The purpose of this repeated load testing is to simulate the pavement condition with number of cycles to see how much permanent deformation is accumulating with time and how Geocell is helping to reduce the permanent deformation. So we had to do both reinforced and unreinforced section, and you can see the reduction of permanent deformation is almost like 3 to 5 times using the Geocells. So Geocells uh, actually helping to reduce the permanent deformation of wrap material. With that, we go forward with construction. But before the construction, we need to do analysis based on TechStart approach, which is linear elastic approach. And for that, we need the modulus, which was for the Geocell reinforced wrap-based layer. We use large-scale test results. For the subgrade wrap and flex-based material, we use resilient modulus test results. And if you look at the location, we had 3 zones. So we had actually the control section, the existing zone had 4 inch of asphalt, but all the newly constructed test location had 2 inch of asphalt at top of it. And if you look at the naming, we have RS1, RS2, and RS3, which are Geocell reinforced section with 6 inch, 8 inch, and 12 inch of Geocell reinforced wrap base layers. And on the westbound side of the pavement, we had 3 unpaved, not unpaved, unreinforced section, which are UR1, UR2, and UR3, which had 6 inch, 8 inch, and 12 inch of wrap base layer without any reinforcement. So we have one control section, three reinforced section, and three unreinforced section to check the performance in the field. And we varied the geocell reinforced section thickness from 6, 8, and 12 inch to see with the increase of thickness of geocell reinforcement how it is improving the performance. So now this slide, I will try to show you the graphics, like how we have constructed our test section. We started with milling, like existing soil was removed, existing pavement layer was removed. Then we put the geotextile for separation. After putting the geocell, it was filled with wrap, but the dump truck are not allowed to move into the geocell because it's gonna make some permanent deformation or damage to the geocell. So it can only uh, put the material close to the edge of the section, and then we use loader to move the geocell further to the move the wrap material further to the geocell pockets. And finally, the scraper was used to make a uniform surface on top of the geocell with the wrap, so that pneumatic roller can finish with the compaction. So these are the equipment used for the construction of geocell reinforced wrap base layer. And to monitor the performance, we actually did some instrumentation on the field. The purpose of the instrumentation was to track the seasonal variation of the subgrade, and we had the westbound lane of the road as reinforced section, and eastbound lane of the road was reinforced section, and the westbound was unreinforced section. If you look at the figure, we used both earth pressure cells, which were located at the bottom of the wheel path, at the bottom of the GRB layer as well. So the purpose was to get the maximum stress observed within this zone. Also, we have used shape array accelerometer. This is kind of a newer technique to measure the in-place movement of soil. It had like 18 segments, and all the segments had the sensor to capture the tilt angle. The tilt angle can be used to measure the deflection. So it can collect the data in any frequency. For this current purposes, we have used like 15 minutes interval. So lots of data were collected from this shape array accelerometer to check the movement of the expansive subgrade with time. So let's look at the field assessment results. When we check the results from the field, we observe that typically Geocell reduce the vertical movement up to 50%. So the comparison between the reinforced and the unreinforced section. And the vertical stress on the reinforced section was like 40% less due to the use of Geocell. Not only the sensor data, we took regular survey to check the rutting or the visual cracks on the road surface. And after the 3 years of construction, we did not record any visual cracks on the surface, which means the use of Geocell helped to reduce the bottom-up cracking. So now we need to know the structural performance of the pavement. TxDOT needs the value, like how it's working, and what value they can use for their future construction in terms of elastic modulus. So we did some falling weight deflectometer test, and that were conducted second year and third year after the construction of the uh, pavement section. So we did several tests within the same reinforced section, and also we did we did it for check the consistency within the same section. And when we look at the results from the falling weight deflectometer, it shows that geocell reinforced wrap base layer, like they had like equivalent elastic modulus compared to the flex material. And not only that, We can also compute the additional confinement offered by the Geocell by modifying the material model with Geocell, and we can see the additional confinement for the RS2 was 7.5 psi, RS1 had additional confinement of 9 psi, and RS3 with the highest Geocell thickness in total had the average increment of confinement was 10.5 psi with the Geocells. With that, there was a question like, what about the permanent deformation? Because when we do the falling weight deflectometer test, it gave us some idea about like elastic deformation. It's not plastic. So is there any way to know the long-term performance and some kind of cyclic loading? This is a new method for evaluating structural performance of the pavement, and it is known as automated plate load test or APLT. So as you can see from the figure, the equipment is mounted on a truck trailer. It can apply cyclic loading with different magnitude and frequencies, and we can measure the deflection. You see in the figure at the bottom is going like cyclic loading, and LVTTs are placed at a distance of 0R, 2R, and 3R distance from the center of the load, where R is the actually radius of the loading plate. And if you look at the table, you can see the loading sequences. So it is using 50, 100, and 150 psi of load with different frequencies. The purpose of doing this test, one is like each section we had two tests, so we can check the consistency or repeatability of the test. And the purpose was to capture the elastic and plastic deformation so that we can prepare the RAT model from here. So let's look at the sorry. Let's look at the results from the APLT. As I said, it can capture both elastic and plastic deformation. So resilient deformation showed that elastic modulus increases with applied stress and frequencies. That means if there is an increase in applied stress, there will be an increase in modulus. And if there is an increase in frequency, there will be also increase in modulus. That means faster traffic will show a higher modulus. That means it was the results show that it has dependency on the frequency of traffic as well. And if you look at the figure on the right, you can see the model that is showing the permanent deformation with increasing number of load cycles. And it's interesting to see the performance for three different pavement was like following the order of the thickness of the geocell. RS1 had the minimum thickness of geocell reinforcement, had higher permanent deformation, and you can see the RS3 had like most 12-inch of geocell reinforced wrap base layer, and it had the lower deformation. Not only that, you can compare with the results with the control section, which is CAS, had 4-inch of asphalt layer, and the performance showed that which was very close to the RS3 layer, even with the 2-inch asphalt at the top. With that, we try to see the RAT model and predict the future future ratting. So as you can see, for this particular case, we had like design life of our 1 million ESL with a rod depth of 0.5 inch. And we use the APLT data to create, take the average value to create a model which can fit the data. And we can use this model to predict the capacity design life of the pavement. And on your right, you can see I've plotted the RS1, RS2, and RS3, and definitely you will see the design life, even with the RS1, was more than 1 million. So we can see the structural performance enhanced with the use of Geocell. Now the question is, if it is performing well, what about the cost? What about the sustainability? Then we started our sustainability analysis. On this slide, I'm presenting the sustainability assessment based on a life cycle cost analysis, or LCCA. The objective here is to compare two pavement design alternatives by looking not only their structural performance but also their long-term economic efficiency. We choose two alternatives. Alternative 1, or A1, used a traditional flex-based material. Alternate 2, we used Geocell reinforced wrap-based material as a base layer. Both alternatives have the same asphalt thickness on top, but differ in the supporting base layer, which influences cost, performance, and long-term sustainability. And for analyzing the pavement, we used FPS 21 as recommended by TechStot. And also we collected the data from the field to measure the cost, which includes the cost of placement and transportation. As you can see, for the flex base material, it was 16.9 USD per yard squared. For wrap, it was 7, and for geocell, it was 6.8. So if you can combine both wrap and geocell cost, which is even less than the flex base material. But for better understanding, we did both deterministic and probabilistic approach to measure the life cycle cost. And if you can see the alternative A2, which is with geocell reinforced wrap-based layer, had slightly better performance in terms of cost. So after looking at the cost, we know like, okay, if this is cost effective, what about the impact on the environment? Is it environmental friendly, or will we have any issue with the geocell reinforcement and the wrap? So we did life cycle sustainability analysis. For life cycle sustainability assessment, we have used PLET, PLET program, which is an Excel-based software developed by UC Berkeley. User inputs involve all the processes involved associated with the material processing, transportation, and any other energy used. For example, if you look at the figure at the bottom, you see like how we are collecting the virgin aggregate material. So we are collecting it by blasting the rock mine, and after that, these samples are transporting to the nearby stockpile or the processing zone where it's crushing to make it like a ready to go aggregate shape, and then it's stored in the stockpile. If you look at the material production and transportation of such material, there are lots of fuel and energy involved, which can be cut down if we use the wrap material, which is recycled asphalt pavement. And that's why use of recycled asphalt pavement will be environment friendly in terms of process and cost of transportation. And not only the flex-based material, since we use the geocell, we need to collect all the information associated with the geocells, how a geocell works, how geocell is produced, and how much environmental impact it may have during the process of production and throughout the life. And as you can see, the main source is the crude oil. And crude oil are then converted to plastic beads, and these plastic beads are used to prepare the high density polyethylene, which is HDPE sheets. HDPE sheets are then stripped into a size which is equal to the thickness or height of the geocell. In the figure number 4, you can see when you do the stripping, you can do in different sizes. For example, 4-inch, 6-inch, or 8-inch size. So after stripping, we do the punching. Doing the punching will create a hole in the geocell panels. This hole will make sure this it will be a drainable, and it will have more interaction to the aggregates located to side. It will provide you more frictions and good for placement and construction. And the next step we did, we need to do the welding. So welding the sheets next to each other help to prepare that cell shape. So if the welding length is more, that means you are making the cell bigger. But we have a like limitation. We cannot make uh, uh, like larger pockets because it will not help to distribute the load. So the pocket size was limited around 12-inch in diameter, roughly. And if you look at the end product is the Geocell panels. So Geocell panels are stored in the industry, and they can be transported to the site whenever the construction is needed. And uh, these in Texas, we do have a lot of manufacturers of Geocells, mostly located within the southern area in Houston. Like most of the cases, they are using it for the unpaved road. But for the very first time, we had the opportunity to use the Geocell for the flexible pavement in Texas, and also supported by the TechStart. So with that, all the process involved in production and transportation of the geocell were considered to check the environmental impact, how much energy and water it is consuming during the production of geocells. So with that, we can see the results in the table. Like for better understanding, instead of A2, I divided the alternative A2 with geocell reinforced wrap base into two columns. One column showing excluding the geocell, just the wrap, and A2 with including the geocell with the including the geocell. So you can see the red arrows are showing the energy consumption and water consumptions are increasing with the addition of geocell. So it was expected. Hence, you are using some HDP sheets into the field. You're gonna have some additional emissions, but since we are using RAP, which is actually controlling the overall emission, and overall production of carbon dioxide is uh, 3 times less with compared to the flex-based material. And if you do the calculations, so we did all the calculation for 1 lane mile. So for 1 lane mile, the reduction of carbon dioxide per lane was 59 tons compared to the flex-based or traditional material. And for all other emission, if you look at the radar chart, it will give you a very good idea, which is like with compared to the flex-based material, the footprint of the A2 alternative with geocell is much less. That means emission is much less and is more environmental friendly with compared to the alternative one, which is the traditional flex-based material. So with now we can say that this solution is uh, providing some environmental friendly nature, so it can be used as a sustainable solution. So with that, I would like to summarize all our findings. As we know, the expansive soil lead to the bottom-up cracking in the pavement, and use of geocell reinforced wrap-based layer can control the bottom-up cracking by reducing the heaving and vertical stresses. And GRB layer allow the use of 100% recycled asphalt pavement in the base layer. I think which is very first time we were able to use in the pavement in Texas. And for the structural performance, the falling weight deflectometer showed that the modulus of the GRB layer is equivalent to the flexes material, so it can be used. And also the permanent deformation, we see like it reduced a lot. An automated platelet test proved that permanent deformation decreases with the increase in the GRRB thickness. Means if we are using thicker geocell layers, we will have more design life. That means performance will enhance. Life cycle cost analysis results showed that use of GRRB is more economic compared to the traditional base material. As you can see, the both probabilistic and deterministic approach showed better performance for the alternative two, which is with Geocell reinforced wrap base. Finally, the life cycle sustainability analysis, which is LCSA, showed us that inclusion of geocell in the wrap base can reduce the carbon dioxide emission by 59 tons compared to the traditional approach for each lane mile. Finally, we can conclude that geocell reinforced recycle base offer better support to flexible pavements, leading to resilient and sustainable flexible pavement design on expansive soil subgrade conditions. I think that's it from my side. Any question?
Thank you very much, Dr. Ashrafuzzaman Khan, for that insightful and technically enriching presentation. We truly appreciate you sharing your expertise and experience with us today. So if you have any question, we have a few minutes for question answers. Please feel free to ask. Actually, I have one question.
Yes.
The whole system looks very interesting, and as the cost is also less and it's also environmentally friendly, it looks like a foolproof system for like expansive soil. But is there any limitation or challenges that you had to encounter using this method?
Yes, obviously. The first challenge is you have to you have to convince any agency because no in this case TxDOT was the agency that we have to prove, hey, we can use the geocell in the field, but uh, we don't have enough data to prove them. So we need some data. We need to convince them to prepare the test sections. And another thing, you cannot construct a full unreinforced section in the main road because they're not going to allow to deteriorate their pavement. So we had a limitation of the unreinforced section used for this study was limited to 1 feet by 15 feet, very small section, which like gave us some idea, but that was the main limitation. Like we cannot do a full unreinforced section with the geocell to prove the performance.
Thank you, Dr. Ashraf, for your answer. I think Abdullah Adam has one question.
Yes, this is Abdullah Adam from Saudi Arabia.
Hi, Abdullah. Thank you for joining.
Uh, s- Thank you, Doctor, for your presentation. Unfortunately, I attend part of them, but the topic related to expansive soil. Why we are not use stabilization by using lime and hydrated lime and cement dust and like that, because if we need to use a wrap, that means we need to, to transport from place to place. This additional cost and so on.
Yes, I think I have the answer in one of my slide. I don't know if you can look at my slide now. I'm sharing.
Yes, yes.
Yeah, so like uh, I should tell you, like my professor, Dr. Anand Pupala, who is expert in using lime for the chemical stabilization, and he wants to promote lime. And as you said, like why not using lime? So the reason that I convince him, hey, if you use lime, which is good, it may be very useful. What about sulfate-rich soil? And sulfate content can vary with time because groundwater is moving. So there is always a challenge. If a trinket can form, we should not use this lime for those kind of soil. And also the curing time. You have to keep the site open and for curing for longer period of time. And if you are doing the rehabilitation project, we don't have enough time. We need to just go and construct within a same day. So that was the main reason I try to avoid lime for this project. Did you get the answer, Adam?
Yes, yes. Thank you, Doctor.
Thank you. Mhm.
Okay, Adrik, I'm taking. I have a question, so I want to ask
Mhm.
it. First of all, Ashraf, it was a terrific presentation. Really, really appreciate it. I also learned a lot, so loved it. I have one question, and it's also kind of similar to the previous question. So, you showed that the geocell didn't work on the subgrade. So basically, on the expansive soil, geocell, sorry, not the geogrid, geocell didn't put any contribution. What do you think? Why it didn't work, or why it didn't put the contribution? I still think it can be. We can make it work some other way.
So if you look at the strain model of the soil, so when we do the resilient modulus test, the strain level is very low. And for the soil to reach its bearing capacity, we need to have larger deformation.
Mhm.
And it may be useful when you are expecting to do like bearing capacity enhancement. That time it may be useful with larger deformation, but in pavement we are not expecting bearing capacity failure. In this case, we are just trying to say to how it can enhance the stiffness of the layer. So that's why for the lower deformation cases, I think geocell is not useful, but for higher deformation, for bearing capacity enhancement, that will be useful. Like unpaved road, that will be useful.
So for this one, have you seen like in terms of the deformation? Have you noticed any deformation, or like the expansiveness went down with yourself?
Uh, we reinforce the base layer, not the expansive soil layer. So what we notice that the typical movement of the bottom of the GRB layer went down compared to the with and without geocell condition, because geocell was acting as a mattress and distributing the load, and there was like 40% reduction of stress, which eventually helped to reduce the overall movement of the expansive soil.
Okay, thank you.
Thank you.
I can see one more raised hand from Shubham Jain.
Yeah, hi, Dr. Ashraf. This is Shubham
Hello.
Jain from IIT Hyderabad, India. So
Mhm.
it's really well presented field study. I have only one query regarding you have evaluated modulus value for GRRB from the laboratory cyclic test, large
Yes.
scale laboratory cyclic.
Mhm.
Can you please explain like what approach you have choose to find that e-values? Because I have seen
Mhm.
uh, you have gone up to I think 1,000 cycles or somewhat
Mhm.
around that. So
Mhm.
can you please just explain those things?
Mhm. Let me go to the slide.
Yeah.
So you are talking about this large-scale repeated load test results, so which was located in UTA that time back in 2015-16 time. And one of the students from Dr. Popala, George, I put the reference at the bottom, 2018. She did this test for us. So uh, there is a like publication where she explained how she estimated the resilient modulus uh, from the result. So when the LBTTs are placed at different location close to the loading plate, and it was able to capture both resilient and permanent deformation separately. So based on that, for each cycle, she was able to prepare the model with some additional lab test data, considering the fixed modulus for the subgrade, and only she needs to calculate the modulus of the geocell reinforced layer with that collected deformation, which is during the each load cycle. So I can share that paper with you, because I didn't personally do all the analysis how it was calculated, but there is a paper I can definitely share with you how the modulus was measured from these repeated load test, and the reference was given in the bottom of which is George 2018. I can also share it with you if you want.
Okay. Thank you.
Yeah.
So if there are no more questions, I would like to thank Dr. Ashrafuzzaman Khan once again for this impactful presentation, and we truly appreciate your time and willingness to share your expertise with the Geo-Lesson community. I would also like to thank all of our participants for joining with us today. And Dr. Ashrafuzzaman Khan, if you have any suggestions for people who want to pursue their career in this direction.
Well, definitely in geotechnical engineering, I think there are lots of challenges. So it varies with the region. So in this particular region, we are dealing with the expansive soil. So my expertise or going aligned with the expansive soil. And also we do a lot of work with the Texas Department of Transportation because they are our funding agencies. So kind of work is aligned with the transportation sectors, but maybe geographically in different location, people may work with a different specific topic. Is someone is doing his research in, let's say, some numerical modeling, tunneling work, maybe northern region like Illinois or those kind of area will be suitable for them. So you can choose, what you would like to do and what type of research you are doing and where you can implement your research. I think that will be more helpful, and you will get more interest to the work. That's what I can say. And I think there are one more question.
Sorry, Doctor. This record or material available to share with us, or
Yes, we will share the recorded material after this webinar.
also please send that paper mentioned by Doctor to.
Okay,
to
I will send. Okay, I will send it to Adrika. I think she can send it to you.
Yeah.
Okay, thank you.
And one last thing, I would like to congratulate Dr. Sadiq Khan for being full professor. It's a big achievement, and it's a big thing to achieve in the academia. Really.
Okay, thank you. Yeah, and it's still very fresh, so I'm still absorbing it. So let's see how it goes.
Dr. Khan, do you want to add something for the people who want to pursue their career in geotech?
I think geotech is a like a really great field to work with. Like, it has a lot of challenge and it has a lot of unknowns. So whoever wanted to work on it can do really great, because everyone is working on like, you will be really good engineer if you handle like challenging problems. So since the problem is great, there are like a lot of room to grow. Very simple, right? And payment is not bad. Civil engineering payment is like, it really doesn't matter that the scale is not very differ from field to field. And in civil engineering, it's always like a sustainable job. Everyone has like a very steady income and a steady job. So this is really great field to work. I personally feel like that. So you're not gonna be like super rich, but you're gonna have a very decent life, right? Yeah. But I really wanted to thank everyone who joined. We started it. This is our third month. So, and I'm very excited to see all the participants, and we hope to see you all again next month. We are still deciding what topic we're going to cover, but very likely we're going to cover something on AI or resilience. So we'll disclose it as soon as we log our next presenter, like next speaker. So really appreciate it on that side.
So we are at the very end of our webinar. So for those seeking professional development hours, participants who attended the live session will receive the PDH automatically. And for those who were unable to attend it, the recording will be uploaded to the Geo-Lesson YouTube channel, and a short assessment link will be shared via email. So we look forward to seeing you in our upcoming Geo-Lesson, as Dr. Sadiq Khan mentioned. So thank you once again from Geo-Lesson team, and have a great rest of your day. Thank you.